2.4, multi-step equations with variables on the same side. And we just did 2.5, variables on opposite sides. Okay, here we go. Example 1. We need to start by getting rid of the parentheses with the distributed property. That's the first thing. You've got to get rid of your parentheses. So I bring down the 7x, and then 2 times x is a positive 2x. And then 2 times 6 is 12 equals 39. And I see that I have 7x plus 2x on the same side of the equation, so that would be 9x. And I still have plus 12 equals 39. And now we're right back to a two-step equation. Every time you simplify, you're going to simplify down to a one-step or two-step equation for multi-step equations. You always get it down to a two-step. And now I can start shifting across the equal sign. I need to use the inverse to do that. Here's the additive inverse of 12 would be negative 12. Whatever I do to one side of the equation, I've got to keep it balanced by doing it to the other side of the equation. There's my 0 pairs of 12 and negative 12, and I have 9x equals 39 minus 12, which would be 27. Now I use the multiplicative inverse by dividing by 9, both sides of the equation, and I get x equals 3. Black day, yeah. Example, let's go to example 3 and do one that has a fraction. I need to multiply 3 halves times 3. So if I make 3x a fraction, I would just multiply straight across. The numerator is 3 times 3x is 9x. And then 2 times 1 is 2. I need to continue distributing that 3 halves to 5. 3 halves times 5. Again, I would make 5 a fraction, 5 over 1. I don't see any cross canceling. 2 and 5 can't cross cancel. 3 and 1. Otherwise, I would do some cross canceling. Multiply straight across. 3 times 5 is 15. 2 times 1 is 2. And that equals negative 24. Now I have a two-step equation. X is being multiplied by 9 halves, and it's being added by 15 halves. I'm going to start solving. The opposite of a positive 15 halves would be negative 15 halves minus 15 halves to the right side. There's my 0 pairs. And now I'm adding fractions, 2 negative fractions. If I make 24 a fraction over 1, I need a common denominator for 1 and 2. Common denominator for 1 and 2 would be 2. So I don't need to change this fraction because it already has a 2. Next to this one, I'm going to create my equivalent fraction. I did 1 times 2 to get 2, so negative 24 times 2 would be negative 48. I have 2 negative fractions that I'm going to add up and keep the same sign. So I have 9x over 2 equals negative 48 and negative 15. 48, 58, 63. Negative 63 halves. This is definitely wouldn't be a problem you'd be able to do in your head, right? Sometimes there's problems you can do in your head, and sometimes there's not. Now I have to finish getting x by itself. X is being multiplied by 9 halves, and so I want to use the multiplicative inverse. What's the inverse of 9 halves? The multiplicative inverse would be 2 over 9. And I multiply the other side by 2 over 9. And you can see that your 2's are canceling, numerator to denominator. Your 9's are canceling, leaving a positive x. And now I'm just going to do some cross canceling. 2 divided by 2 is 1. 2 divided by 2 is 1. And then I see 63 and 9 can cross cancel as well. I can divide out a 9. 9 divided by 9 is 1. Negative 63 divided by 9 is negative 7. So when I multiply straight across, negative 7 times 1 is negative 7. 1 times 1 is 1, which is just negative 7. All right, let's do one that has decimals. And again, the first thing that I need to do is distribute. Get rid of those parentheses. So 1.2 times 3a, I can just think about 12 times 3. 12 times 3a is 36a, but then I need to adjust for the decimal place. How many decimal places do I need in my answer? When I do 1.2 times 3, how many decimal places do I need? I need 1, so that's 3.6. And then 1.2 times negative 1 is negative 1.2. And I bring down my 8.9. And I start to simplify anything I can that's on the same side of the equation. I see 8.9 minus 1.2. I can combine these two together. So I have 3.6a. And then 8.9 minus 1.2 is going to be 7.7. That's a positive 7.7. Now I have a two-step equation. A is being added by 7 and 7/10, and A is being multiplied by 3 and 6/10. So I can start to solve now that everything's simplified. The additive inverse would be negative 7.7. Lining up my decimals, we get 3.6a equals 7.2. The multiplicative inverse of multiplying by 3.6 would be to divide by 3.6. Or the multiplicative inverse would actually be 1 over 3.6 multiplying by that. All right, so we have A equals, just forget about the decimals for a second, is 72 divisible by 36 evenly. By how much? 2. So 3.6 times 2 would give me exactly 7.2.